Hey everyone, this is FixReef, and today we have another Apex EB832 up for repair. This one came in claimed to be water damaged. Because of that, I'm not going to plug it in to power to test right away, and instead I'm going to take it apart and see what it looks like on the inside. But first, the external inspection. Since this is presumably a water damaged unit, I'm looking for some signs of corrosion, usually around these ports. And in fact, you can see, let me see if I can zoom in, that there is indeed corrosion happening here and here, and in fact even here in this inside of these ports. So I would imagine that there is probably a significant damage on the inside as well. So let's take it apart and see what we find out. External corrosion on these units is not all that uncommon, primarily because, I mean, they are around, in the environment where they're surrounded by salt and moisture, and so the older these units are, the more common it is to see the screws that are rusted on the outside. The big question is what the inside looks like. We're about to find out. I also suspect that this has been taken apart as well previously. I can see a little bit of plastic bend here and there. Okay. Well, on the surface it does not look too bad. There is definitely some corrosion, and I think that I can smell some burned components as well. Well, first we are going to go ahead and disconnect the face plate. Again, this ribbon cable is fairly delicate, so we want to be careful around it. And with the face plate gone, let's see what we find. There is definitely corrosion over by where the ports are. You can see that there is quite a bit of corrosion around it. Quite a bit of, I'm not sure if this is all corrosion. There is some corrosion here, no doubt. But there is also salt creep everywhere. So I would imagine that this unit was at some point exposed to the salt water from the area where the ports are, because everything else seems fairly clean. This area where the 24-volt power supply is seems clean on the surface, and most importantly, this area here is mostly clean, except for maybe this part of the outlet has a little bit of white residue on it. Also notice that, let me zoom out. Also notice that this 12-volt power supply is our favorite old power supply, which fails for every single EB832, and we'll have to, if we were to fix this unit entirely, we'll have to upgrade caps on this unit to something a little bit more reasonable. But for the time being, we're going to attempt to take this apart further and see if anything else is corroded. First, I'm going to attempt to remove the 24-volt power supply, because this could be a problem as well. A problem area, I should say. Yeah, there is definitely damage. There is certainly damage to the underside of this, but I'm not seeing burned marks. Doesn't mean that this is working, but I'm not seeing burned marks yet. I will have to reflow a few things here where salt got rid of some of the solder, so that would have to be replaced. But other than that, the back doesn't look particularly bad. Let's look underneath the main board. Just looking at it without the microscope, the only issue I'm seeing is right in here in this corner. It could be a problem, but right here there's definitely some oxidation, and it looks like a resistor that corroded. Okay, not a big deal. We'll clean it all up fairly well. All right, I'm not seeing anything else. From this point, we can safely assume that this unit went into the water this area first. And it's actually a good thing that it went this area first and not, but it didn't go further out, because this area is all low voltage area. This part of the power supply is a low voltage area. Here is where we have AC, high AC voltage coming in. This is where AC voltage, obviously all of these outlets are AC voltage, but this area is all 12 and 24 volt low voltage lines. We'll just have to find out what might be broken. I think what I'm going to do next is I'm going to attempt to remove. What I'm going to do is I'm going to attempt to remove the this smaller board here with connectors off of the main board, take it apart and see what needs to be cleaned up, if there is anything that's clearly burned that needs to be replaced. Okay. This faceplate separates pretty easily, and you can see that it's connected to the, that's just the power, and it's connected to the main board at this point, and this point. I'm not sure if I'm going to disconnect all of this. Maybe just remove the back and attempt to desolder the connector board from the main board and inspect everything under the microscope. All right, the connector board is connected to the main board in this row of pins all the way down here, and there are 2 rows up here. So first of all, before we attempt to remove it, I'm going to attempt to remove as much of the unleaded solder as possible, and then add quite a bit of leaded solder and see if I can get the connector off that way. Let's add some flux. The issue with unleaded solder is that the melting temperature for it is much higher than leaded solder. So when we attempt to remove a connector like this, for us to remove it successfully, we have to apply quite a bit of heat to the area. And applying heat to the area as we rework things is never a good idea. So we want to apply as little heat as possible for as short of a time frame as possible. And for this, we don't want to use the leaded solder at all, unleaded solder at all. So far, it looks like we are doing really good removing unleaded solder. See how nice and easy it is? When you have proper flux, when you have a good wick, it just works much better. Okay, now that I've removed the unleaded solder, I'm going to attempt to remove the connector itself. The problem is that this connector has quite a few pins. I'm looking at it probably about 15 or so, 14 to 15. When we're dealing with this type of complex connector, we cannot easily remove it without using a low melt solder. Low melt solder is a fairly expensive type of solder, but you only need a little bit of it, and only in circumstances like this where you have a connector that is fairly big and you don't want to damage the main board or the port itself by removing it. Low melt solder, by the name of it, contains solder that has extremely low melting temperature. And as a result, it only requires fairly low temperatures to melt the entire surface and have the connector removed. So we're going to make sure that it bonds really well. You can kind of see how well it works here. See that these 2 connectors, these 2 pins are connected via a copper trace. Watch what's going to happen to this pin when I'm warming up this pin here. Can you see that the pin on the left started to melt as well? That's because it's enough of the heat transfer across the trace over to this side to completely melt it. So it's going to work wonders as we attempt to remove the connector. Okay, everything's looking pretty good. Finally, it's time to take a much closer look at the connector board, because this is where the majority of the corrosion is. Well, let's get started. This is just salt. This is just salt. You can see that salt ate away at this pin over here where there was solder. That solder is mostly gone, so we'll have to reflow. We'll likely have to reflow this as well, although it's in a better shape. Let's look on this side. Also quite a bit of salt creep. This pin I also have to see, but it looks like this pin is completely disconnected because there is very little solder on it. Let's see what's going on here. So this is the disaster area. There is corrosion. You can see that there is green salt creep, which basically is salt mixed with copper. So it must have eaten away at the copper traces. Yeah, this area is pretty bad. The big question I have right now is, did it cause trouble with the traces? And if so, to what extent? Because everything else is repairable, replaceable, but if traces are, there goes our resistor. I'll have to see what value that thing is. No, actually not a resistor, it looks like it's a diode. Okay. There's another one of those over on this side as well. All right, let's clean up the area a little bit from all that salt, see what the surface looks like. You may also send this board through the ultrasonic cleaner just to make sure that all of this is gone, even from inside connectors as well. All right, let's see. This is the biggest problem area over here where the diode was initially installed. This, I think the traces are salvageable. Okay, now let's see what we can do about this pad that is mostly corroded. That's where the diode was installed previously. A lot of corrosion. But the good news is that you can see it on examples where these are installed. So here's our set of diodes. These two items are connected together. So this pad and this pad are connected, and this pad and this pad are connected. So even if these traces are all gone, if these pads are all gone and not functional, I can probably attach the diode instead to this trace, assuming that it's in a better shape. And that's a big if. So definitely ate away at a lot of this copper. Finally freed this pad from salt oxidation. This is awesome. There's actually good copper underneath. I feel much better. Okay, hopefully you can see now that the pads are showing some good shiny copper underneath. Okay, that's looking real good. Connectors also look a little corroded, but this is going to be taken care of by ultrasonic cleaning. I'm just going to help it a little bit by removing large chunks of oxidation. Let's see if we can tin this exposed copper. I don't like when copper is being exposed like this because this is going to attract moisture and it's going to cause further oxidation. So we'll have to tin this nicely with some really nice leaded solder. At this point, I'm going to take this board to ultrasonic cleaner, and I will be right back. But before I place this board into the ultrasonic, I'm going to reinstall the diode that fell before. All right. All right, this now looks nice and solid. Now let's clean everything up. The board is now back from the ultrasonic cleaner. Let's take a look at what we have. It looks really nice and clean. A little bit of residue here and there, but most of the salt is gone. Now let's take a look at the connectors. All of the oxidation is gone. Look at this nice shiny surface of the pins. Yeah, all of the pins look really, really nice, like new. This is definitely salvageable. Now that the connector board is clean, let's see what else we need to do. Looks like we need to clean up a little bit of residue on the main board as well. Get rid of all of this oxidation marks. Now before I reinstall the connector board, I would like to clean up the connectors. There's so many pins on this board that it's going to be difficult to reinstall it without every single pin being nice and clean. So let's remove all of the solder from those pins first. Now that all of the pins are nice and clean, let's reinstall the connector board. Now the board is in place. It is in place fairly securely. So let's flip the main board around and solder the entire connector board back in place. Before we complete this repair, I'd like to make sure that the pins are also soldered nicely on the inside, because there are several traces and several pads on the inside of the board that these pins need to connect to. So I'll need to examine and solder those pins that need to be soldered. It looks like the lower two pins are looking pretty good. So maybe a couple pins at the top that need to be secured. All right, this looks pretty good. Let's clean up. Now that everything is clean, let's flip it over and do some testing. First, I'm going to plug it into power and see which LEDs come up. All right, so it looks like on the 24-volt power supply, the green LED is on. Let's check the 12-volt power supply. I have to be very careful because it's under live voltage. I'm not sure if you can see this, but the red LED on the 12-volt power supply is also on, so that's a good sign. Now let's test some voltages on the connectors. First, the 12-volt connectors, the AquaBus. 12 volt on the AquaBus, excellent. The second connector on the AquaBus, also 12 volts. And the last one, also 12 volts. Now let's check the 24-volt connectors. Got 24 volts on one of them. Also about 24 on the other. And 24 on the third. Looks like all the 12 and 24-volt connectors work. What I will do behind the camera is I'm going to upgrade the 12-volt power supply to better capacitors so that we have a reliable power supply, and we'll reassemble and do some final testing. Okay, so I've upgraded the 12-volt power supply to proper capacitors. If you're interested in how it's done, please take a look at my earlier video where it's described in great details. Now, I assume that this EB832 is completely repaired. We've cleaned up the entire extension board with all of the 24 and 12-volt connectors, resoldered it back. It looks beautiful. Let's just see if it works. To verify that it works, I'm going to not only test the voltage output of this, but also whether or not it's going to handle an appropriate load. So we're going to test the AquaBus ports for 12 volts, about half an amp load, and maybe about an amp load on the 24-volt ports. To do this test, I have a couple of custom-made ports, custom-made connectors here. These are standard Molex connectors that go into the 24-volt ports with some male header pins on the outside, on the other side. So I am not going to be able to easily test the 2-pin connectors currently, just because it's not connected to an Apex head unit, because these connectors are actually controlled by relays. But the 4-pin 24-volt connectors are on all the time as far as power goes, and they also handle data, AquaBus data over them. So let's plug it into. It doesn't matter which port, because they all share the same 24-volt input. Okay. I'll plug in the EB832. We're hearing clicks of the relays, which means that the outlets are, some of them are on anyhow. All right, now let's connect our load tester. All right, so right off the bat, we've got 24-volt output. That's a good sign. Let's apply about an amp load and see what happens. All right, looks like we're handling that load pretty easily. Again, I'm looking for drop in any of these numbers. If I see a drastic drop, either voltage goes down to almost zero or amperage goes down, the current goes down to almost zero, I know that there is a problem. But as long as these numbers are stable, we know that the 24-volt board is working. Yeah, it definitely can provide 1 amp fairly easily. Now let's disconnect that load. And we are going to connect AquaBus, 12 volts. Make sure that those work well. To be careful not to short anything. All right, so we have 12 volts. Load on. Let's give it about 450. And it looks like it can handle the 450 milliamps pretty good. Okay, I think this is all we needed to know. Both of the power supplies, the 12 volt and the 24 volt outputs are working pretty good. So we can assume that this repair is complete. We'll just need to reassemble. I'll do some final testing for data communication and whatnot. Make sure that it can talk to Apex, make sure that it can switch all of the outlets on and off. And this EB832 will be ready to go back into service. Let's clean up all of the debris from water damage that's inside here. It's nice and clean. We'll clean up the outside as well at some point. Rice. I was wondering what was a piece of something that was stuck in between this outlet. That was rice. So when this EB832 was water damaged, they likely put it in a bag of rice to try to dry it up. I guess I'll use this opportunity to discuss the drying with rice myth, because it is a myth. You just saw what was the inside of this EB832 looked like when it was water damaged. No amount of rice is going to help deal with the water damage from salt water. Rice is not going to help whatsoever. just don't even bother. You see what needs to be done properly to fix this. It needs to be opened up, it needs to be cleaned, it needs to be washed. Immediately all of that salt needs to be removed to help it, to avoid the oxidation. No amount of rice is going to help with this. It doesn't work on these devices, it doesn't work on phones, it doesn't work on laptops or iPads. Do not use rice if you have something falling into water or having any kind of water damage. Rice is just not going to help. It's an urban myth that just never works. Trust me, I have been working on these devices for a very, very long time. It does not work. Once water, especially salt water, gets inside, it immediately starts reacting with copper, with metals, and it's immediately going to start the oxidation. Even if you were to absorb the humidity inside with rice, which it will never do fully and entirely, there is still salt that's going to keep eating at the copper. So don't even bother with rice. It does not work. Okay, let's plug it in one last time to ensure that it actually still works once assembled. You can see that the status LED is on and blinking. In a couple of seconds, it should switch on the indicator LEDs for the outlets as it's going into fallback, not able to communicate with Apex. And status LEDs are on. I see at least 3 of them turning on, so that's a good sign. I will do some testing on the communication ports once I connect it to Apex later, but for now, this EB832 is happy again. Let's review what we've done. We have had corrosion around the ports on this side of EB832. It fell in water or somehow got water damaged on this side. You could see that on the inside, the entire board holding all of the connectors was badly corroded and some components missing or dislocated. We cleaned it up with ultrasonic cleaner. We've replaced components. We've reflowed the pins and pads that were corroded to make sure that they're nice and clean and fresh and have very good connection. We also tested all of the outlets, 12 and 24 volts, to make sure that what we've done actually now delivers voltage that it was designed for. So all of that works. And as always, with most of my repairs, I also upgrade the 12-volt power supply to use capacitors that will last longer than 1 year of warranty. That's provided by Neptune for these types of devices. Thanks for watching. If you like this video, please like and subscribe, and I will see you next time.